In an interview, the popular U.S. astrophysicist Neil deGrasse Tyson warned that when we discover things in space, they will shock us. We learned from Voyager 1 that they have 775 new unknowns flying by in space, and they are amazing. They've been traveling for 45 years now, and what Voyager 1 finds every day still surprises researchers. A quote from Neil deGrasse Tyson: "Once you're outside the zone, it's not really clear if there's much that will change for you because at that point you're wandering around out in interstellar space. If we find something other than nothing, that will be interesting." Neil deGrasse Tyson's words serve as a reminder that in 2012, Voyager 1 crossed the threshold out of the solar system into interstellar space, and we know virtually nothing about that space yet. We will have found anything we can or will find there to be a big surprise. We're getting measurement data from a sphere that's mysterious for the first time. Most of the universe consists of its interstellar medium. We cannot always imagine the dimensions because there are such vast, empty spaces between the stars. Scientists have been brooding over what this interstellar medium might look like and what it is like for the past few decades. But it's a complete first when Voyager 1 sent data back from space for the first time. 12 years after launch, Voyager 1 and 2 have now been exploring the solar system and space together for more than 40 years. Originally, their main mission was to explore Jupiter and Saturn, actually only a short mission. In the mid-1970s, NASA decided to move fast and built 2 probes to take advantage of an once-in-a-lifetime window to distant planets. In the late 1970s and early 1980s, there was such a unique window between Jupiter, Saturn, Uranus, and Neptune that we could send probes out far using very little fuel. With each planet the 2 passed, the probes would get fresh momentum via a gravitational maneuver, and the route was calculated so each was at the other planet. As a result, the flight time to Neptune was cut to only 12 years rather than 30 years. Voyager 1 and 2, pure mechanicals which could not be adjusted or readjusted, were put together quickly and launched into space from the Cape Canaveral spaceport, the west coast of Florida, in the summertime of 1977. The probes were supposed to last 5 years, and NASA was worried that even these 2 would make it to their first destination. So unerringly did the 2 probes fly, and so perfectly did they perform their mission, that NASA contemplated using the 2-planet mission as a 4-planet mission almost immediately after the launch. For Voyager 1's visit to Jupiter, NASA chose to fly past the most interesting object seen nearby at that time, the moon Io, which had more than 10,000 trajectories available for its close flyby. Another target was chosen to be Titan for the trajectory around Saturn. Saturn exploration went well, and after it was validly decided that the spacecraft was fit to fly on. To Uranus, Voyager 2 headed for the last of the outer planets. As NASA sought additional funding for the mission, they were already planning the Uranus flyby to gain the advantage of getting the Voyager 2 to Neptune in one whack. The pale blue Uranus was photographed for the first time when Voyager 2 swept close on January 24, 1986, and examined Uranus's moons, its magnetic field, and fine rings. By the time Voyager 1 set out on its way to the edge of the solar system, Voyager 2 was already on that journey itself. The second mission objective for this probe was also clear: this magical boundary between the end at which the sun's magnetic influence would begin to wane, and the start of interstellar space at the heliopause, from which point this magical boundary starts to expand faster than the speed of light. It is an area full of unsolved scientific mysteries. Voyager 2 made it to Neptune only 312 years after the very first visit to Uranus, on August 25, 1989. Scientists saw the deep blue gas giant in all its glory for the first time. The probe also found unusually active geology on Neptune, seen a large dark spot like Jupiter's red spot, and found extremely strong surface winds. But today, we know that nowhere else in the solar system do storms rage as ferociously as on Neptune. Voyager One was moving at about 520 million kilometers an hour on a roughly 35 degrees angle above the ecliptic plane, approaching the heliopause. The probe flew through the outer edge of the solar system on Aug. 25, 2012. Voyager 2 would complete its mission to Neptune and take a course at an angle of around 48 Righer's above the ecliptic, to give itself time to reach the edge of the solar system, at around 550 million kilometers per year. Its identical twin was traveling slightly slower. The probes scanned particles, measured their surroundings, and detected sources of ultraviolet radiation throughout the flight. NASA announced after the close of the main mission that both probes discovered, photographed, and studied more than 775 unknown objects, features, and planets in the flyby. The mystery of interstellar space. Can you imagine a space that probably has neither a beginning nor an end? The true mystery of the universe, that spans billions of kilometers between spirating stars, is probably bigger than you imagine, and is most definitely a mystery. Happy to be interstellar medium. The largest part of the universe is this space. That looks like an empty blackness, like a nothingness that is just there, but researchers know that can't be everything. The universe's most enigmatic wallpaper fills this space. It's the remains of exploded stars, and it's very likely that the interstellar medium is made up of the very structures that hold the universe together or make it possible in the first place. The Voyager Interstellar mission is tasked with unraveling the wonderful space inhabiting beyond the furthest frontier and well beyond the sphere of influence of the Sun. The start of this extended mission was really with the first flight through the heliopause boundary, the outermost boundary of the Sun's magnetic field, where the solar wind meets the forces and radiation of interstellar space. Previously, this had never been able to be measured. It allowed the solar wind to be measured at the outermost edge of the heliopause and to find out what happens to it as it interacts with the interstellar medium. Even our solar system isn't held in a static place in the universe, or even the galaxy. We're hurtling through interstellar space at breakneck speed. We want to measure fields, particles, and waves at the edge of the solar system, and learn about the dynamics of the motion of the solar system in the galaxy and in the universe. Today, we can divide the passage of the probes into 3 phases. With the next several decades of NASA missions planned on the termination shock, the heliopause exploration, and finally the entry and exploration of interstellar space, it seems rather unlikely that the individual upper heavenly bodies will be mapped out. When the Sun's magnetic field still dominated the environment, however, it was when the magnetic field in the Sun was quite weak during their lifetimes. The environment was dominated by the plasma flows from solar winds. The loss of supersonic, solar wind speed, and significant plasma flow and magnetic field changes at and within the loss of supersonic solar wind speed region define the termination shock, which marks the first step of the transition into interstellar space. The heliopause exploration phase began after the termination shock phase by passage through the termination shock. The bubble the Sun generates around itself with its winds is its heliopause. Solar winds and particle streams are constant streams of particles blowing through the entire solar system. The Sun and its planets are protected by a ball, the heliosphere. These currents envelop it. The solar wind and the magnetic field dragged along with it by the Sun still hold the outermost, or the heliopause layer overprotected from the rest of the galaxy. In December 2004, Voyager 1 crossed the heliopause, and in August 2007, Voyager 2 did also. The Sun's influence in thinning out is beginning to fade in this region, and interstellar space is starting to reappear. On August 25th, Voyager 1 finally flew beyond the heliopause and is now within interstellar space. It was the first man-made object to cross this threshold. Voyager 1 was at about 122 AU, 18 billion kilometers, away from the Sun when that happened. The heliopause seemed to end suddenly, almost from the moment to the moment. Up until now, they believed that the heliopause was just gently merging with the interstellar medium. Apparently, at this point, the forces from the solar winds and space form something like a wall. These measurement results from Voyager 2 on November 5, 2018, were taken on a completely different date from crossing the heliopause into interstellar space with Voyager 2. That is the unexpected level of solidity in the solar system edge, and shows that the edge probably has to be the same everywhere. Excitement in the interstellar medium. Voyager 1 is now collecting a wealth of data that has already dramatically changed our knowledge of space, but all this is in interstellar space. Measuring plasma waves in interstellar space found the space between the stars more full than expected. This is plasma, ionized gas, that is a good indicator of the overall activity and dynamics of the interstellar medium. We measured that the interstellar plasma has about 0.05 particles per cubic centimeter, which is higher than in the outer regions of the solar system. So that means that the heliopause is thinner than interstellar space. Nobody had expected this, and so, again, researchers were astounded. The probe also measured the level of cosmic rays in interstellar space, as expected, much higher than at Earth's distance. High-energy particles that come from all over the universe are what these rays are made up of. These particles would very probably produce fatal radiation for us on Earth. Thus, our life is only possible because we are wrapped in a cloak of solar plasma streams which envelop us around our star. We were very excited at NASA in 2021. Wild data from the probe's Attitude Articulation and Control System, AACS, reported such crazy data that on rare occasions scientists briefly wondered if Voyager 1 had shrunk its brain cells or been abducted by aliens. Navigating Voyager 1 safely requires it to know where it is in space, and the AACS, or Autonomous Attitude Control System, consists of gyroscopes and star sensors used to make sure it knows its location. The probe, it said, had lost orientation in space. The entire object was perfectly aligned, but surprisingly they were still. The probe wasn't spinning, and it hadn't become misaligned. Voyager 1's antenna always points towards Earth. So it was, doing what it was designed to do. While the data continued to arrive safely, they said Voyager had lost its position. How this confusion arose took weeks to find out. Finally, the engineers found the error. But the probe was on course, and the onboard computer system apparently had switched independently, generating confusing position data. Since then, and after rectifying the problem, Voyager 1 has since flown relatively unperturbed through the interstellar medium. The main scientific instruments have enough power and fuel for the Voyagers to operate until at least 2025. Voyager 1 will be about 122 million miles, 22.1 billion kilometers from the Sun at that time. Voyager 1 will travel 1.6 light-years, about 40,000 years, past the star AC +79, 3888 in the constellation Giraffe. Subscribe now because the best videos are yet to come.